Hey guys, I'm Craig Enders and thanks for checking out the Blimp video channel. In this video, I'm going to talk about interaction effects in Blimp, and I'll describe how to specify manifest variable interactions, latent by manifest interactions, and then interactions involving pairs of latent variables. I describe how to set up latent variable models in a separate video. Before we get started, I want to thank the Institute of Educational Sciences for all their support and point you to the project's webpage. You can download Blimp at the same website. To make the illustration more concrete, I'll use data from an educational study. The file includes assessments of broad reading in first grade and ninth grade, and there's also teacher ratings of learning problems from the first grade. Notice that all three variables have missing data. Let's start with a moderated regression that features the first grade variables predicting ninth grade reading performance. I'm going to treat learning problems as the moderator variable here, so the goal is to figure out whether reading scores in first grade are more or less predictive for students with elevated learning problems. In the path diagram, the two arrows that converge into a single arrow represent the interaction effect. Let's take a look at some of the key commands from the Blimp script. First, I center the two interacting variables to enhance the interpretation of the lower order terms. The product term is specified by joining the two predictors with an asterisk on the model line. So it's important here that the product isn't a new variable, but rather a function of the two lower order terms, either of which could have missing data. Researchers often want to probe interaction effects by computing conditional effects or simple slopes. With a pair of manifest predictors, you can use the simple command to get the effect of the focal predictor at different levels of the moderator. To specify conditional effects, you put the focal predictor to the left of the vertical pipe, and the moderator goes on the right of the vertical pipe. This looks like a fairly standard moderated regression model, but I want to take a second to describe the underlying specification so that you can understand how Blimp might differ from other software packages that you've used. Blimp uses something called a factored regression specification. The basic idea is that we want to avoid working with a multivariate distribution and instead represent that distribution as a series of submodels, each with its own distributional assumptions. This specification is really important for interaction models because the incomplete predictors require features like heteroscedasticity that are incompatible with a multivariate distribution. By default, Blimp assigns a multivariate distribution to exogenous predictors like the first grade reading scores and learning problems. Outcome variables like ninth grade reading scores have a univariate distribution. So under the hood, Blimp actually represents this model as two submodels, each with its own unique distributional assumptions. Exogenous predictors like the first grade scores can either be normal, binary, ordinal, or nominal, and univariate outcomes can take on a much broader range of metrics. I'll discuss multivariate models in a minute. Putting it all together, this is the entire Blimp script with the model commands we just talked about highlighted. I described the other commands in different videos. Each dependent variable in a model has its own regression summary table. I described the composition of these tables in a different video, but for review, the median column contains the point estimates, the standard deviation column contains measures of uncertainty, Bayesian standard errors, a 2.5 and 97.5 are credible intervals, essentially Bayesian confidence intervals, and then the rightmost columns are frequentist test statistics. Looking at the coefficients section, the lower order term for the reading predictor is 0.40. Now remember that we centered the predictor variables, so that's the effect at the mean of the moderator, at the mean of the learning problems variable. The interaction slope is positive, which means that the strength of the association between first and ninth grade reading scores increases as learning problems in first grade increases. So essentially, first grade reading scores are more predictive for students with higher levels of learning problems. The simple command produces conditional effects or simple slopes at plus or minus 1 and plus or minus 2 standard deviations from the mean. We can see that the slope at 1 standard deviation above the learning problems mean is nearly twice as large as the slope at 1 standard deviation below the mean. Let's modify the model and use a binary moderator. So instead of a continuous dimension of learning problems in first grade, I'm going to classify students into two groups according to whether or not they exhibited any learning problems. This is the analysis model both as an equation and as a path diagram. For the incomplete binary variable, we'll use a probit regression formulation that links the binary indicator to a normally distributed latent response variable, which I denote as an oval in the path diagram. The dashed arrow is a link function that connects the latent responses to the dummy code, and it's that dummy code then that functions as a predictor variable in the focal model. Finally, the two arrows that converge into a single arrow represent the interaction effect. The main pieces of the Blimp script are identical to the previous example. The main new wrinkle is that I list the binary variable on the ordinal line to invoke a categorical variable model. The product term is specified by joining the two predictors with an asterisk on the model line, and then just like before, ask for simple effects of reading at different levels of the learning problems variable. With categorical moderators, Blimp produces simple effects or conditional effects at every level of the moderator. I want to take another minute to describe the factored regression specification so you can understand what Blimp is doing under the hood. Like the previous example, Blimp represents the analysis as two submodels, each with its own distributional assumptions. The exogenous predictors have a multivariate distribution, and outcome variables like 9th grade reading scores have univariate distributions. When we have categorical predictors like the learning problems ratings, it's actually the underlying latent response scores that link to other manifest predictors. In the path diagram, the curved arrow represents the correlation between the predictors, but that correlation is actually linking the manifest reading scores to the underlying continuous dimension of the learning problems ratings. That nuance doesn't affect the focal model because it's still the dummy code that predicts the reading scores and acts as the moderator. This is the regression summary table for the analysis. Focusing on the coefficients section, the lower effect of reading, 0.39, is now a conditional effect for students who are 0 on the dummy code. So this is the effect of first grade reading scores for students with no learning problems. The positive interaction term tells us that the students with learning problems in first grade have a slope that's higher by about 0.34. The simple command now produces conditional effects or simple slopes at each level of the binary moderator. We can see that the slopes for the two groups are 0.39 and 0.73. Next, let's change up the analysis so that we have a binary moderator and a latent variable as our focal predictor. So instead of using a single composite reading score, I'm going to use 4 subtests as indicators of a reading latent variable in first grade. I describe how to set up latent variable models in a different video. This is the new analysis model both as an equation and as a path diagram. The probit regression model for the binary predictor is the same as before. We now have a reading latent variable with 4 indicators, and I've constrained the first loading to 1 for identification. By default, Blimp sets the latent variable's mean to 0. In the path diagram, the two arrows that converge into a single arrow represent the latent by manifest interaction. The first thing we do is use the latent command to define a new factor. The entire measurement model is specified with a single line of code by assigning the reading latent variable to the 4 indicator models on the right side of the arrow. In the previous examples, the predictor variables were exogenous and manifest, so Blimp automatically set up the multivariate model behind the scenes without any intervention on our parts. When we have a latent variable predictor, we need to specify that multivariate distribution manually. In the path diagram, that multivariate distribution is represented by the curved arrow connecting the manifest predictor and the latent predictor. In the syntax, this correlation is specified by separating the latent variable and the manifest variable with a double tilde. Like before, the interaction effect is specified by joining the two variables with an asterisk. Finally, the simple command gives the conditional effect of the reading latent variable at each level of the categorical moderator. Before we go any further, I want to show you how to do a little bit of housekeeping. So now we have multiple models in the model section, and by default, Blimp prints out the summary tables in alphabetical order. To improve the workflow, we may want to reorder the information on the Blimp output. This is the same script as before, but now I use labels in the model section to control the order of the output tables. The structural model will be printed first, the measurement models will be printed next, followed by the predictor models. You can name the labels anything, they just have to end in a colon. The factored regression specification for the analysis is the same as before. The latent and manifest predictors share a bivariate distribution, each of the indicators has a univariate distribution, and the outcome variable in the structural model also has a univariate distribution. This is the summary table for the structural model. Looking at the coefficients section, the reading slope, 2.56, is again a conditional effect for students with no learning problems in first grade. The positive interaction effect tells us that the students with learning problems have a higher slope coefficient. The simple command produces conditional effects or simple slopes at each level of the binary moderator. We can see that the slopes for the two groups are 2.56 and 5.32. As a final example, let's look at a model that has the interaction between two latent variables. Procedurally, latent variables are no different from any continuous variable. They just happen to have 100% missing data. So when we specify this model, it's going to look really similar to the manifest variable interaction that we started with. Now I'm using latent variables to represent both first grade predictors. The learning problems latent variable now has 4 subtests as its indicators. The first loading is fixed at 1 for identification, and the latent variable's mean is automatically set to 0. The 2 arrows that converge into a single arrow represent the interaction effect. First, I use the latent command to define the 2 latent variables. Then I specify the 2 measurement models by assigning the latent variables to the indicator models on the right side of the arrows. I specify the correlation between the latent variables by separating the variables by a double tilde. Finally, I join the 2 latent variables with an asterisk to get their interaction in the structural model. Notice that I label the 3 coefficients in the structural model. I'm going to use these labels next in the parameters command to compute the simple slopes. The factored regression specification for this model represents the multivariate distribution using 10 submodels, each with its own distributional assumptions. The latent predictors share a bivariate normal distribution, each of the indicators has a univariate distribution, and the dependent variable in the focal model also has a univariate distribution. The simple command works with a lot of different models, but not every model. I want to show you a different way to compute conditional effects that you can use 100% of the time. The top equation is the familiar expression for a simple slope. So we have estimates of B1 and B3, we just need to substitute in different values of the learning problems latent variable. I'm going to use the parameters command to compute the simple slopes at different levels of the moderator. First, let's compute the simple slope for students at high levels of the moderator. Because the learning problems latent variable is an outcome or dependent variable in the model, we can access its variance at each iteration by appending .totalVar to the variable name. Then putting that in the square root gives me the standard deviation of that variable. So this line is simply programming the simple slope equation from above. To compute the simple slope at the mean of the learning problems variable, we substitute in a value of 0 since the latent variable is centered, and so the simple slope simply equals B1. Finally, the simple slope at 1 standard deviation below the learning problems mean looks like this. This is the regression summary table for the structural model. Looking at the coefficients section, 3.62 is the conditional effect of first grade reading at the mean of the learning problems variable. Then the positive interaction coefficient again tells us that that slope becomes stronger, more positive as learning problems increases. The simple slopes appear on a new table labeled generated parameters. Values in the median column represent our point estimates of the simple slopes, and we get credible intervals and significance tests for each. We can see that the simple slope gets stronger as a student's level of learning problems increases. That concludes our brief tour of interaction effects in Blimp. This video only really scratches the surface of what you can do, and virtually any variable in your model can interact with any other variable. Among other things, you can have different types of moderators, moderated mediation, multi-level moderation, and 3-way and higher order interaction effects as well. Different types of nonlinearities like polynomial terms for latent variables are also possible. In the graphical interface, you can access the user guide through the help menu, and you'll find many different types of interaction effects in the analysis examples. Thanks again for tuning in. I hope you check out other videos.